Finishing up the note sheet from Thursday, and I think we got through the unit circle, yes? Got all the different parts labeled. Okay. So what we're going to do is use this unit circle to evaluate sine, cosine, tangent, secant, cosecant, and cotangent for these functions. Actually, back up, make a new page. Actually, I think this is where we're at. Because we were on the back side of the unit circle. We hadn't finished it. Because we had theta, 30 degrees, or pi over 6. 45 degrees, or pi over 4, or 60 degrees, or pi over 3. Then we had sine, cosine, and tangent. And across the top we had 1/2 square root 2 over 2 and square root 3 over 2. Then we had square root 3 over 2, square root 2 over 2, or 1/2. Because I just remember that I think, got about this far on the back side of the sheet, yes? Now the part we didn't get to is tangent. Because I'd gone through kind of an explanation of how we can really look at tangent as sine over cosine. So really what we can do is if we know what sine and cosine are, we can always get back to tangent. Even if it's not one of these nice angles, because really what we're doing is putting sine over cosine. So for 30 degrees, we can think of it as 1/2 divided by square root 3 over 2. Sine divided by cosine, which is going to be 1/2 times 2 over the square root of 3, which is 1 over the square root of 3, and if we rationalize it, we end up getting the square root 3 over 3. And we could do the same with 45. Well, luckily 45 degrees is a little bit nicer, because what are we dividing? Square root 2 over 2 by square root 2 over 2. Anything divided by itself is 1. And the last one works out to be the square root of 3. I find this nice, especially if we're trying to look at, say, tangent of an angle, because it's easier to look at. Now, I also have this over to the side. So are we good with this here? Yes? So below this, we can write these here just so that we can think about these. Sine of theta is equal to y over r. Cosine of theta is equal to x over r. And tangent of theta is equal to y over x. Cosecant of theta is equal to r over y. Secant of theta is equal to r over x. And I'll step out of the way here in a second. And cotangent of theta is equal to x over y. And these here are somewhat helpful, especially if we start looking at points on a coordinate plane, and how the values work with the given angle. So sine and cosecant are really 1 over. We're flipping it. So if I have sine's value, sine of a given angle, if I want cosecant, CSC, all I've got to do is flip it. So if we said sine of 30 degrees, well, I can look at the table we just put down. Sine of 30 degrees is 1/2, yes? So cosecant, CSC of 30 degrees, we flip the 1/2, and it becomes 2. So as long as I know sine, cosine, and tangent, I can find those values. We can find the other three. It's just flipping it. It's 1 over. So let's look at this next part here. Evaluate the 6 trigonometric functions at each real number. So we can look at A first. A is pi over 6, yes? Now looking at the unit circle, we can say sine pi over 6 is equal to. Well, according to the unit circle, we're at that first one, or we can use the one down below. Sine is our y value, if we're looking at the unit circle in the ordered pair, yes? And the y value at pi over 6 is what? 1/2. Or if we looked at the table on the back side, we would see that for sine of pi over 6, it is 1/2, yes? Now let's look at cosine of pi over 6. And what is it going to be? Square root 3 over 2, yes? Now we're finding all 6, so the next one we're going to look at is tangent of pi over 6. Now, tangent of pi over 6, we can look at the unit circle, do sine over cosine, so 1/2 over square root 3 over 2. Or you can look at the back of the sheet at our table, and it says tangent of pi over 6 is square root 3 over 3. Any questions on this so far? So we good with these three so far? Yes? Now the next one we're looking at is cosecant of pi over 6. Cosecant of pi over 6. Now cosecant is going to be the same as 1 over sine. Cosecant is the same as 1 over sine. So we could write it out as 1 over 1/2, which is the same as 1 divided by 1/2. Well, we don't divide fractions. We change it from division to multiplication, flip the second. Multiplying together really just to say that this is 2, yes? Now, if doing this and kind of flipping these is somewhat challenging, you're not as strong with this here, or rationalizing the denominator when we have a square root, the TI-30XS, those little yellow calculators will do it for us. It'll actually calculate the whole thing out. So for us here, cosecant is 2. Secant of pi over 6. So this time we're taking what? 1 over square root 3 over 2. We're flipping it. And really, if we flip it, it's just going to be 2 over the square root of 3 if we flipped it. But we can't leave it in this form. We have to rationalize it. And when we rationalize the denominator, we end up with 2 square root of 3 over 3. And I'm going to write this off to the side so that y'all can see it, because again, I could have typed 2 over the square root of 3 in the graphing or in the yellow calculator, hit enter, and it would have given us the answer. And really what it's doing is it's taking this here and multiplying it by the square root of 3 over the square root of 3. We're essentially multiplying it by 1. That's all it's doing. Now the numerator is going to be 2 square root of 3. but the denominator, the square root of 3 times the square root of 3, square root of 9, which is just 3. So it's really, all we're doing is trying to get the radical out of the bottom of the fraction. Questions on this here? And last but not least, cotangent of pi over 6, which is just going to be 1 over tangent, or we flip tangent, which would be 3 over square root of 3. And again, if we rationalize this here, we get just the square root of 3, incidentally. And I can show you this here, because again, we'd multiply by the square root of 3 over square root of 3. Well, the numerator is going to be 3 square root of 3. And just like the last one, the denominator will simplify to 3. But this time we have 3 over 3, which simplifies to 1, telling us it's just the square root of 3. Any questions over this here, how we found sine, cosine, tangent, cosecant, secant, and cotangent? No? Now, probably trying to keep secant and cosecant, these two here, straight of which one they work with, is I always think it's kind of the opposite. CSC has a whole bunch of C's, but it doesn't connect with cosine, it actually connects with sine. SEC starts with an S, but it connects with cosine. They kind of got it flipped. It'd have been better. I would have thought it'd been make more sense if secant connected with sine and CSC connected with cosine, but it doesn't. It's kind of flipped that way. Any other questions on these here? We're ready to look at the next one. 5 pi over 4. So we can look at sine of 5 pi over 4. And again, I would come right back here. I would come right back to this unit circle and see where is 5 pi over 4. We're all the way down in the third quadrant, yes? And if we look at that there, so sine, the y value, is negative square root 2 over 2. Cosine of 5 pi over 4, incidentally, is negative square root 2 over 2. Well, just looking at what we have on the board, does anybody have a guess at what tangent's going to be? 1, because it's sine over cosine. So we're dividing sine and cosine, and well, if sine and cosine's values are the exact same, it simplifies to 1. Now, we haven't dealt too much in reference angles, but 5 pi over 4 is pi over 4 greater than pi, yes? Pi over 4 minus pi. You don't have to write this out. I'm kind of just showing you guys this. Because if we're subtracting pi from 5 pi over 4, that'd be 4 over 4. And 5 minus 4 is 1, so we're left with pi over 4, yes? That's kind of back like the first one. Or if we looked at our box, our kind of table that we have on the back for this here. So what are the values for pi over 4, 45 degrees? Well, we have square root 2 over 2. For sine, square root 2 over 2 for cosine, and 1 for tangent, yes? So we can still use that, but with this here, which quadrant are we in? We're in the third quadrant, yes? Sine and cosine in the third quadrant. Let's go on and finish this one up here. So we'll look at the rest of this one here. So we found sine, cosine, and tangent. Those weren't too bad. Secant, cosecant, and cotangent are just flipping it. So for secant of 5 pi over 4, really we're taking sine and flipping it over, which would give us negative 2 over the square root of 2. And we'd never leave it in this form here. We don't leave a radical in the denominator. And the really only reason we don't want to do this is because we don't like leaving an irrational number, a non-repeating, non-terminating decimal in the bottom of a fraction. It's just not standard practice. Now we can go through the process of rationalizing the denominator, writing it out by hand, so multiplying it by the square root of 2 over 2 and simplifying that way. Or the nice yellow calculators will do it also. And what this works out to be is just negative square root of 2. Just a negative square root of 2. As if we rationalize it, we would have negative 2 times square root of 2 over 2. 2 over 2 would simplify. So we found secant, cosecant. Well, what do we think it's going to be? Same thing, negative square root of 2. Because for this one here, incidentally, even if you did flip secant and cosecant, you flipped which one it was connected to, it didn't make that big of a difference because it worked out to be the same thing. And the last thing we're looking at is cotangent of 5 pi over 4. So we're flipping 1, which would be 1 over 1, which is just 1. And that's it. Questions on these here? Not too bad. All right. Let's look at the next one, pi. So we can look at sine of pi, cosine of pi, and tangent of pi. So looking at the unit circle, pi is straight across 180 degrees, yes? And according to this, sine is what? The value of sine is? We are now ready for the junior boys to go to the library and have their pictures made. Junior boys. 0, because sine is the y value. And cosine is the x value, so we have negative 1. So for this here, sine is 0, cosine is negative 1. Tangent is what? Sine over cosine. So that would be 0 over negative 1, which is 0. So we good with these here so far. Now, we can look at cosecant of pi. Well, cosecant is what over what? Or what are we flipping? Sine, yes? So this is going to become 1 over 0. Because even with 0, we can put it over 1. Can I divide anything by 0? No. So cosecant, CSE, is undefined at pi because it's 1 over. So 1 over 0 is undefined. So there are values of secant, cosecant, and cotangent that are going to be undefined. And there's values of tangent that are undefined. But sine and cosine will always have a value. Now, secant of pi, so we flip negative 1, which gives us negative 1, because it would be 1 over negative 1, which is just negative 1. And that brings us to cotangent. What do we think cotangent of pi is going to be? Come on. It's also undefined. Because tangent's what value? 0. If sine, cosine, or tangent is 0, if any or all of them are 0, its reciprocal is going to be undefined. So if sine is 0, cosecant is going to be undefined. If tangent is 0, cotangent is going to be undefined. Well, that also works the other way, because if, say, tangent's undefined, cotangent's going to be 0. Well, if cosecant or secant is 0, well, that's not going to work. Because if cosecant or secant is 0, it means that sine or cosine would have to be 1 over 0, which isn't true. Because sine, cosine will always have a value. So secant and cosecant will never be 0. It just doesn't work that way. Any other questions on this here? We'll finish it up here, or finish up today's lesson with negative pi over 3. Sine of negative pi over 3. Which quadrant would we be in? 1, 2, 3, or 4? Because if we're talking negative pi over 3, we're starting at the positive x-axis and going down, yes? Well, we would be in the 4th quadrant. Another way we can look at this is saying negative pi over 3 plus 2 pi. I can find its coterminal angle. I can find the other angle that will work out the same. Because if we did this here, we'd get 5 pi over 6. And if we look at the unit circle, not 5 pi over 6, I'm looking wrong spot. This should be, let's see here, because that there, let me actually work it out so that we can confer on this here. Because for this to work, we need the denominators to be the same. Because 3 times 2 is 6. Yep. Which does indeed give us 5 pi over 3. Because if we look at pi over 3, it's up at 60 degrees, yes? Or negative 60 degrees is going to be at 300. Does that kind of make sense where we're at? Because all I'm looking at is a unit circle and trying to get it in a form that I can work with better. Because we know negative means we're going to go clockwise, not counterclockwise, down pi over 3, that amount. So we can think of it that way, where in the first quadrant of the unit circle, this here is pi over 3. So since it's negative, it's actually telling me this amount. Where if we went all the way around here, this is 5 pi over 3. 5 pi over 3. Where 5 pi over 3 and negative pi over 3 are going to give us the same amount. So it's going to be which one is it going to be easier to work with. Does this kind of make sense how we got there? Now, we can look at that quadrant, negative pi over 3, and sine, the y value is negative square root 3 over 2. Our cosine's value is 1/2. Tangent of negative pi over 3. Well, I don't need that, actually. So we would do what? Sine over cosine, yes? Well, one of them is negative, the other is positive, so we know it's going to be negative, yes? It works out to be square root of 3, and we'll finish this up tomorrow. And